Hello, geometry, and welcome to Unit 10, Lesson 3. See the title, tangent lines. These are actually they're very unrelated to the tangent that we did earlier in the semester. It doesn't have anything to do with trig. It's just another form of tangent. Okay, so what is a tangent? So a tangent to a circle is a line that intersects the circle in exactly one point. Okay, the point where the circle and tangent line intersect is called the point of tangency. So I got a picture there. Let's just transfer these vocab words to the picture. So in the figure above, name the tangent line. So the tangent line would be the line AB. All right. Name the point of tangency. Well, the point where the line touches the circle is point A. Name the tangent ray. Well, this is really no different. It's ray AB and segment AB. I'm just showing you that it could be a line, it could be a line segment, or it could be a ray. All of them could be tangent. Okay. So there are some theorems associated with tangent lines. Theorem number 1 is coming now. If a line is tangent to a circle, then the line is perpendicular with something specific. It's not perpendicular with everything. It's perpendicular to the radius that is drawn to the point of tangency. So in the figure above, which I'll scroll up in a second, the radius to the point of tangency, which is OA, forms a right angle with the tangent line. Therefore, the measure of angle BAO equals 90 degrees. So let's go up there real quick just to point that out. So I said in this picture, the radius to the point of tangency, so O to A, forms a right angle with the tangent line. So that angle is 90. Now here's what a lot of people get mistakes people make. They see that point of tangency and they see any line that goes to that point and say, oh, that's a right angle. No, that's not true. It's got to be the radius, or at least has to go through the center. So you might see something like this where it's a full diameter. Well, the diameter includes the radius. So yes, that is a right angle, because that's what the first theorem says. And now we'll do a couple practice problems with that theorem. Given that ML and MN are tangent to circle O, find the value of X. Well, what you see there, it looks like a kite. With the next theorem that I'm going to show you, I could prove that it's a kite, but right now we can't, but it looks like a kite. Regardless, it's a quadrilateral. Okay, MLON is a quadrilateral. So that means all the angles add up to 360. That's great, but how does that help me? Well, if I know that ON is a radius and N is a point of tangency, I can say that that's a 90-degree angle. The same thing above. OL is a radius and ML is a tangent line. So that's a right angle. Well, now I can say that 90 plus 90 plus 117 plus X equals 360. And subtract everything and you should get X equals 63. Okay. Next one. Find the area of the circle. I'm asking a little different here. The area, I need pi r squared. So as long as I can get the radius, I'm good. Well, I don't have the radius right now. Before I go any further, that 17 is the measurement from here all the way to here. Okay. Well, what am I going to do? If I could find OB, I'd be able to answer this question. How am I going to do that? I have two sides, but that's all I've got. I can only use the Pythagorean theorem if I have a right triangle. Do I have a right triangle yet? Not necessarily. But then if you use the theorem that I just showed you, you can understand that this angle here is a right angle. And now I can do the Pythagorean theorem. So x squared plus 15 squared equals 17 squared. Right. And then I think you get x squared equals 64 when you do that, and you get x equals 8. X is your radius, so now it's pi times 8 squared, so 64 pi units squared is the area of the circle. All right. Let's go ahead and go to the back. Does this figure show a tangent line? Explain. Okay, so kind of working with this theorem backwards. I gave you all three sides, 5, 15, and 16. If it was tangent, it would make a right angle. If it made a right angle, then the Pythagorean theorem would work. So we're going to check the Pythagorean theorem here. So 5 squared plus 15 squared, does that equal 16 squared? So 25 plus 225, is that equal to 256? You should see that it is not. So 250 does not equal 256. So is that a line tangent? I can for sure say that it is not. Since the Pythagorean, I'm going to say it. You know what? I'll type it. Since the Pythagorean theorem did not work, we know the angle is not 90 degrees. Therefore, the line cannot be tangent. Okay, hopefully that explanation makes sense. Okay, let's move on to the next one. The next one involves some more advanced algebra. Okay, find the value of x in the circle below. So you will see this one. The 7 is from here to here. So that's what 7 is. So the whole distance here is what? Well, it's x and 7 together, so x plus 7. Okay, so that's the first thing I want to point out. Second thing is, I told you, I didn't say it, but I'm going to say it now. The line is tangent. I'm going to tell you that the line is tangent. I'm giving you that. You do need to know that before you can go any further with this one, because if it's not, then that's not a right angle. But the fact that it is, that makes that a right angle. And I can say x squared plus 10 squared equals, and then it's the whole hypotenuse squared. So the whole hypotenuse again is x plus 7 squared. The left side's nothing tricky, x squared plus 100. But the right side, x plus 7 squared, is not x squared plus 49. Don't do that. X plus 7 times x plus 7, you're foiling this. X times x is x squared. X times 7 is 7x. 7 times x is 7x. And 7 times 7 is 49. So that simplifies to x squared plus 14x plus 49. All right, so now I'm going to solve that equation. I'm going to subtract x squared. Nice thing is the x squareds cancel on both sides, and I'm left with 100 equals 14x plus 49. Subtract 49, I get 51 equals 14x. I'm going to get a nasty number here. And I'm just going to go to the nearest 10th. So x equals 51 over 14. That's the exact answer. To the nearest 10th, I would say is about 3.6. Okay. So that's using that first tangent line, which says that the tangent line and the radius to the tangent line form a right angle. Theorem number 2 says the two segments tangent to a circle from a point outside the circle are congruent. Now, by itself, like in the picture here, it's a pretty easy theorem. When you start applying it down below, you'll see that it can get a little tricky. So in this figure, point E is outside the circle. Oh, duh, right? EC and ED are tangent to circle A. What this theorem is saying is we can conclude that EC and ED are congruent. So how are we going to use that, and what's that going to look like? The perimeter of triangle ABC, we want to find that. Given that circle O is inscribed in triangle ABC. First thing you need to understand is what inscribed means. Inscribed means that the circle is tangent to the triangle at 3 spots. One for each side of the triangle. So D is tangent, the point of tangency. E is a point of tangency, and F is a point of tangency. Now, if you look at this I'm going to do some coloring here. Just looking at that part right there, B is a point outside the circle. BD and BE are 2 lines of tangency. So that means BD is congruent to BE. Again, by itself, that's not an issue. So I can say that's 15 centimeters. Okay. Now I'm going to go ahead and erase everything. Start kind of fresh here. What I will see a bunch of people do is put the wrong sides with the wrong, put the wrong sides at the wrong spot, I guess. So we just said BE is also 15. What's AF? Hopefully you see that AF is 10. It's not 8, it's 10. Because AD and AF are congruent. And then EC would be 8 centimeters. Now, there's a couple ways you can find the perimeter. You could take each individual number and add it up. So 8 plus 15 plus 15 plus 10 plus 10 plus 8. Or you could find the whole side. So 8 plus 15 is 23. 10 plus 15 is 25. And 8 plus 10 is 18. And then add those up. Either way, you're going to get the right answer. So 18 plus 23 plus 25 is 66 centimeters is the perimeter. Okay. There are other ways that I will ask that question, give you different information, but it's basically all the same thing with those types of questions. And that's it for tangent lines.